Hello everyone, my name is Kevin McLean. Today we're going to be talking about fire suppression in temperate conifer forests, specifically in the central and southern Cascades of Washington and Oregon. So just a quick overview of some of the things that we're going to be talking about in this presentation. We're going to discuss where the region is and what types of plants and animals are there. Douglas fir versus the western hemlock trees, which are the dominant trees in this region. What the historical and the current fire regime are of the area, what a mixed severity fire regime is, and how that aids the heterogeneity across the landscape and how that bolsters biodiversity. And then what causes some of the changes that we're seeing in the fire regime, and those are anthropogenic and climate related. So we're also going to be talking about the implications of these changes that we're noticing in the fire regime, and that includes the increased risk of high severity fires, loss of biodiversity, loss of ecosystem services, and many others. And lastly, we're going to talk about what managers can do now to build resilience to change and major disturbances in the future. Here we see a map of the temperate conifer forests and specifically the ecoregion of the central and southern Cascades forest there, which is highlighted in the sage green. So the northern and western slopes of the Cascade Range generally are wetter than the eastern and southern regions of the Cascades. Um, and the southern and eastern regions are characterized by more ponderosa pine forests and then kind of grading out to high desert and sagebrush steppe. And the western edge of this region grades out into the Willamette Valley, which was historically oak savanna, which was maintained by Native American ignited fires, but has now been almost entirely converted over to agricultural and urban land. So I wanted to concentrate a portion of my studies on Silver Falls State Park, both because I work there and also because areas like this have been subjected to extremes of anthropogenic influence. So they were subjected to Native American ignited fires first prior to the mid-1800s, and then logged pretty heavily for nearly 100 years before being adopted into a protected area where both logging and fire activity have been strictly excluded. So we know that protected areas are often more at risk for high severity, high mortality crown fires because of the exclusion from all types of disturbances, which increases the density of the trees and alters the fuel loadings. And this was evidenced in the Hayman fire at Cheeseman Lake in Colorado in 2002, which burned over 138,000 acres in a high severity fire in a land that was protected from disturbance. Here's a closer view of Silver Falls State Park outlined in the lime green there. It's a 9,000 acre internationally renowned park. And you can see the extensive agricultural conversion over to the left of the park there. And you can also see that it's pretty topographically complex, which lends to a patchy burn distribution at the times when it did burn. And then I do want to point out right under the Silver Falls State Park title there, you'll see a small brown patch, which I'm highlighting right now here. And that was a 30-acre low-severity burn that occurred in 2018 from a lightning strike. This burn was pretty quickly suppressed by authorities, largely because of the political pressure to save Silver Falls State Park, which is dubbed the crown jewel of Oregon State Parks. And the state was still reeling from a 47,000 acre burn over in the nearby Eagle Creek area the previous year, which had outraged local communities. And so I also want to just point out that even without these outlines around the protected areas, it's pretty obvious to tell which areas are seeing an exclusion from disturbances just because of the sheer density of the trees. What is here in the region, it's characterized by having steep valleys and ridges due to volcanic and glacial activity of the past. And this kind of lends itself to the mixed severity fire regime and patchy burn distributions. There's also numerous streams and lakes due to the high amount of precipitation. And then Silver Falls is kind of a mid-range elevation between 350 to 600 meters. So past historic disturbances include fire, volcanic activity, winds, and floods, and then occupancy by Native American tribes, which ignited fires as well. Dominant tree species in the area is going to be the Douglas fir, which comprises about 80% of Silver Falls State Park, and then noble fir at higher elevations. Fire exclusion and canopy closure has severely limited the regeneration of these species, but instead favors more shade-tolerant western hemlock and then Pacific silver fir at higher elevations. Anthropogenic fragmentation of the whole landscape is caused by logging, fire suppression, and commercial tree plantations, which replace diverse later seral stage stands with dense monocultures of trees. So here's just a quick visual of the Douglas fir on the left and then the western hemlock on the right. Um, Douglas fir are going to be more fire tolerant trees. They have thicker bark, and then the seedlings prefer bare mineral soil or very thin litter layers. They're fairly shade intolerant. They can form some semi-thick canopies, which you can see, of course, from the satellite image of Silver Falls State Park. And they make up approximately 70 to 80% of the current overstory at Silver Falls. Then looking at the western hemlock, that is pretty fire intolerant. It has thin bark, and then the seedlings prefer rich, thick, moisture-retaining litter layers. They are the most shade-tolerant tree of the region, and they can form very thick canopies, which exclude recruitment of other types of species. And then here in the Silver Falls State Park, they make up approximately 80 to 90% of the new accruitment that's happening, at least in the closed canopy portions of the park. So those numbers are pretty significant. We're seeing a drastic shift to western hemlock in the coming decades. So in addition to the Doug fir, the western hemlock, and the Pacific silver fir, we do see some occurrence of both grand fir and noble fir, which are primarily left over from some of the tree farms that were in the area that were then absorbed into the state park. And western red cedar is another big one, red alder, and then a whole assortment of other trees and shrubs, including some of the invasive species. So here's just a couple more shots that I took of some of the understory trees coming up. You'll see on the photo on the left here, pretty much all of those young trees are western hemlocks. And here's a shot of the burned area at Silver Falls 1 year after the burn. And you can see again, a lot of these are western hemlock trees, which are expected to die just because of the fire completely girdling the base of the trees there. Talk just a little bit about some of the fauna of the area and emphasize that really the plant biodiversity and then the patchiness of the ecosystem and then the niches that patchiness creates really translates into the animal biodiversity. So here we actually have the photo of the northern spotted owl, which is an endangered species. They're pretty resilient to fires, um, but they're endangered just because of loss of habitat primarily. And then, of course, increasingly closed canopy forests are changing the behavior of owls and other raptors, and of course, how they hunt for prey in the understory. Um, and then forests with sort of these mixed severity regimes are really support some of um, the broadest array of animals because they support species that prefer um, some of the earlier seral stages, the mid-seral stages of development, and then the later seral stages of development too. Some of the other animal species of the area are the black-backed woodpecker, black-tailed deer, black bears, raccoons, beavers, and then mountain lions. So just like some plants are fire dependent, many animal species also rely on burned areas for a portion of their life history, or they rely on the edge effects created by fires and the patchiness of the distribution of fires. Increasing canopy closure and then decreasing plant biodiversity contributes to losses in the endangered animal species like the northern spotted owl. So what is a mixed severity fire regime? Well, it's exactly what it sounds like. It's kind of a mixed bag. They're less understood than some of the other fire regimes, mainly just because they're not studied as often. And they occupy a niche between lower elevation forests that generally receive frequent low severity fires and then higher elevations that generally receive more infrequent higher severity fires. So the Silver Falls area was historically low severity to mixed severity fire regimes. And then the mixed severity is going to be characterized by 20 to 70% of trees being killed by the sum of fire effects. And I would just like to emphasize that this is not always a direct killing of trees by a crown fire. What we see in the 2018 burn at Silver Falls was because it was primarily western hemlock. A lot of those trees, even though they were just burned along the base of the tree, they're going to most likely die just because of that burn kind of girdling the cambium there, and just because they're fire intolerant trees. So mixed severity fire regimes are also characterized by patchy burns, which are influenced by the topography, and they produce rich intermediate scale beta diversity, which provides a wide variety of habitats across landscapes. This also increases the edge effects, and they are influenced by top-down and bottom-up factors. How has the fire regime changed in this area? Well, like many areas across the western U.S., we are seeing trends towards less frequent but more severe crown fires, especially in protected areas, and then the associated effects of that. We're seeing bigger and more widespread homogeneous burn patterns, which is inconsistent with the mixed severity regimes. Fire return intervals, which shift from 20 to 40 years to 150 or more years, and then shifts from fire tolerant open canopy forests to more fire intolerant closed canopy forests, and then later successional forest types. So what has caused a change in the fire regime? Anthropogenic land use changes have the most direct effect on temperate conifer forests, especially in areas closer to development like central and southern Cascades. And then arguably the second most influencing factor is going to be climate change. However, this may play an increasing role in the future. Part of anthropogenic changes are the European occupation of the American Indian Territory, which resulted in reductions in ignitions, logging, and grazing from introduced domestic cattle. Active fire suppression in the early to mid 1900s. Agricultural farming and grazing land conversion. This includes clear cutting, planting monoculture stands, and farming. Fragmentation of the landscape, and then invasive plant and animal species, including domestic cattle, which have greatly affected the fire regime across the United States. Climate-related causes. Most ecologists tend to focus on the increased fire risk due to the land use changes, but the effects of climate change are receiving increasing attention and recognition because of their contributing effects. And studies show that in areas of the Rockies that are largely unaffected by man, we are seeing an increase of fires and fire severity. This is important to note that if the natural world is shifting towards an increase in high severity fires, and yet we keep suppressing them and allowing fuels to accumulate, it is sooner or later going to lead to a devastating fire that the temperate conifer forest will likely be unable to recover from. So climate-related causes, we see increased length of fire season, increased duration of burns, increased high severity burn frequency, and then changes in oscillations of temperature and precipitation due to climate change. What are some of the implications of the changes in the fire regime and the climate change? Well, we have a greater risk of high severity, high mortality burns. This often results in the greater carbon losses, greater risk to human life, especially in the wildland-urban interface, greater associated costs for suppression and mitigation, potential loss of ecotourism income, like in the state parks, loss of ecosystem services. There's also less chance of regeneration and recruitment for trees, which equals less resilience and resistance to disturbance. Increases in even age stands and more homogeneous distribution of vegetation. And then an increased chance of ecosystem shift or dominant species shifting, like we're seeing from a Douglas fir to western hemlock. We also will be seeing and we are seeing a decreased biodiversity of plants and animals, losses of habitat for endangered species like the northern spotted owl, other apex predators like other raptors and mountain lions, um, the migration of plants and animals as temperatures and abiotic factors shift, and we'll likely see cascading effects on understory plants, animals, insects, even underground biodiversity and microbial activity there. Increased extreme weather events, increased chance of erosion and sediment deposition, which will threaten the watershed, and of course the waterfall attractions of Silver Falls State Park. So here are some recommended action items for management on ways to build resilience and resistance. And some action items for Oregon State Parks specifically. We need to do an immediate reassessment of fire suppression policies. We need to recognize that grasslands and savannas are not the only ecosystems that benefit from fire. This is, of course, widely known in the scientific community, but doesn't always see its way into policy on the management level. There are only 2 to 3 intermittent prescribed burn projects in Oregon State Parks of the 255 parks that are managed, and those are in grasslands and savannas. We need to follow bigger agencies' examples. There's a total of 58 national parks um, which use human ignited prescribed burns to simulate the role of natural fire in certain ecosystems. And there's 46 areas and nearly 58 million acres of national parks, which are classified as natural fire zones, where naturally ignited fires are allowed to burn under managed conditions. So we could possibly adopt the national forest zoning approach that considers the wildland-urban interface and the associated fire risks when it designates action for each zone. So a zone 1 would be a suppression of all fires and rely only on thinning and fire mitigation. Zone 2 would be prescribed burning applied. Zone 3 would be application of prescribed burning and or naturally ignited managed burning. So that is a potential solution to that can be adopted by the state park system, especially in areas that are heavily populated or close to the wildland-urban interface. So in addition to doing the prescribed burns, fire mitigation, and just being more intentional about allowing or suppressing naturally ignited fires, we can concentrate more efforts on invasive species removal, and we can utilize policies that support an adaptive resilience approach. And that's going to be, in our case, fostering the growth of Douglas fir and other more fire-tolerant trees, and then thinning fire-intolerant trees. Because Douglas fir handles both fire and the future climate conditions for the region better, it provides better resilience. And this is part of managing for the future conditions of the region, which are going to be influenced by climate change and, of course, more anthropogenic pressures. And thank you very much for listening.